Welcome to the video on how to do some of the prerequisite skills for your freshman Algebra 2 course. What I recommend that you do is kind of work through some of these examples maybe on your own, try your best on them, and you can watch the video to kind of guide you through the problems that you're not sure how to complete, or you can use this to kind of check. And then what I would do is use the other versions of the assignment to try on your own and make sure you practice and have these skills down pat, ready to go to start your freshman year Algebra 2 class. And then you'll find that you'll probably start off with a very nice start to the school year. What I'm going to do is I'm going to go through each of these, and as I scroll through problem to problem, the software that I'm using erases the stroke, so if you need to go back and look at it, you're just going to have to rewind the video. I'm going to start off with number 1. Now, number 1, you have to add fractions. Now, keep in mind, guys, there is no calculator allowed. So you're not going to just be able to simply type this in. You're going to have to do it by hand. So if you kind of remember back in 5th grade when you learned to maybe add fractions, or 6th grade, you have to get a lowest common denominator, or the same denominator, in order to add the fractions. And so when I compare the LCD of 4 and 8, that would be 8. It's the smallest number that both 4 and 8 can divide into. So what I'm going to need to do is when I rewrite this negative 1/4, in order to make it have the denominator of 8, I need to multiply that denominator by 2, so that 4 times 2 becomes 8. Now if I multiply the bottom by 2, I need to multiply the top by 2. On the other hand, this 1/8 already has my denominator of 8, so I don't need to multiply that guy by anything. Now when you multiply fractions, we multiply top to top and bottom to bottom. So the number -1 times positive 2 is going to be -2, and then 4 times 2 is 8. And now I can simply add 1/8 onto that, and because they have the same denominator, I can write the denominator as 8 and combine -2 plus 1 together to make -1 in the top, positive 8 in the bottom, and that would be the sum of those two fractions. Let's see if we can take a look at number 2 while we have it on the screen. For number 2, it's a similar kind of problem. The one thing you may want to do, though, is change the way that 8 over -3 is written. And instead of having like the -3 in the bottom, because I'm dividing a positive number by a negative number, the overall value of that fraction is negative. So I could just rewrite this as -8 over 3. It's still just a negative fraction, and then I'm going to add 9 over 4. Now in this case, the denominators of 3 and 4 are definitely not the same. I have to get an LCD of 3 and 4, which is the lowest common multiple of the numbers. That would be 12. That's the smallest number that both 3 and 4 can divide into. So that means I'm going to need to multiply this first fraction by 4 in the bottom, so 3 times 4 can become 12. And that means I have to multiply 4 to the top. In order to make this fraction have a denominator of 12, I have to multiply it by a 3. So that means I have to multiply top and bottom by a 3. So if we do the multiplication for the first fraction, I'm going to multiply -8 times 4, that's going to be -32, and then 3 times 4 is 12, plus, if I multiply these guys, 9 times 3 is 27, and then 4 times 3 is 12. Now that's great because they have the same denominator. I can rewrite the denominator as a 12, and then I can write -32 plus 27 as my numerator. Now -32 plus 27, that would be -5 over positive 12. And if I could reduce the fraction 5/12, I would, but since I can't, I have to just leave it. For number 3, I'm going to try to multiply these fractions together. Again, you don't have the use of a calculator, so we have to do this by hand. The first thing that I'm going to try to do when I try to multiply fractions is multiply all the numerators together and all the denominators together. And so I need to change 5 so it's written like a fraction, so it's a little bit easier to do this. So I can change this problem to be -4 over 8 times 1 over -7 times 5 over 1. Now, there's a couple ways you could do this. And I could right away just multiply all the numerators together and all the denominators together, and that would be my result. The only thing is, because I don't have a calculator, I'd like to keep the numbers as small as possible. And since I'm multiplying all of these numbers together, right, I'm multiplying everything in the top and everything in the bottom. If there's any factors that are common to both the numerator and denominator, I'm going to cancel them out. So for instance, I know that I can divide 4 into 8 2 times, and that 2 is the remaining factor in the denominator. So really, I can just multiply the numbers -1 times 5 in the top, and in the bottom I can multiply 2 now times -7 times 1. So that would just change into, what, -1 times 1 times 5 is just going to be -5, and then I have 2 times -7 times 1, that's -14, and negative over negative is going to be a positive quotient, so it's really 5 over 14. Now, you could have multiplied the numerators together to get -20, and the original denominators together to get, what would that be, -56, but then you'd have to divide out a 4 from the top and the bottom to end up with the -5 over -14, which would give you the same answer of 5 over 14. The only problem is, simplifying a fraction, with big numbers might get a little trickier without a calculator. So I suggest canceling common factors if you can first. Okay, and number 4, we're trying to evaluate, basically find out what this number is equal to. Now remember, you cannot just simply type this into a calculator. You have to do this by hand. So hopefully, when you see this, you recognize you're squaring the number -9, which means you're multiplying -9 to itself. So there's 2 negatives that are being multiplied here. That is very important because hopefully you know that when you multiply 2 negatives together, it makes a positive. So the final answer will be a positive 81, not negative. On the other hand, in this problem, I have -4 to the third. That just means I'm multiplying -4 to -4 to -4 3 times, right? I have 3 negative factors. Now, if it were just these 2, that would be positive because a negative times a negative is a positive, but multiplying that positive answer to yet a third negative factor would make it negative. So the final answer here is going to be negative, and if you multiply 4 times 4, that's 16, times another 4, that's going to be 64. So the answer is -64. Now, if you look at number 5, this, you might think at first glance, is very similar to that first part of number 4. But you'll notice there are no parentheses around the -9. That is very important. That means this is really just -9 times 9. The only thing that's being squared really is the 9, not the negative. Okay, so I'm only multiplying a 9 times a 9 with a negative in front, or if you want to think about it, a -9 times a positive 9. Either way, you're multiplying a positive times a negative, and that stays negative. This is going to be -81. So again, the key is if there are parentheses around the negative, you need to include it in your multiplication. If there are not parentheses around the negative, you do not need to include it inside the parentheses. It should just be one negative out in the front. Okay. Now this one, number 5, is the second part's a little tricky. How I would change this one is as follows. I'm going to copy down that negative, and now I have -2 in parentheses 3 times. So since it's -2 to the third, I really have the product of -2 3 times. Now if we look at this carefully, I have 1, 2, 3, 4 negatives. If you have an even number of negatives, that will make a positive answer. Since I can kind of pair up these 2 negatives to make a positive, these 2 negatives to make a positive times a positive will give me a positive. But if I multiply 2 times 2 times 2, that gives me 8. So the answer is just positive 8. Okay, in this problem, we are doing some more evaluating with fractions and powers. So just like before with the -9, the negative's in parentheses, so that means I'm really multiplying -3/2 to -3/2. I do need to include the negative on the inside of the parentheses because it's on the inside there, so it's got to be on the inside here. First off, I know a negative times a negative will be a positive answer, and now all I have to do is multiply numerator to numerator and denominator to denominator. So 3 times 3 will give me positive 9 in the top, and 2 times 2 gives me 4. So the answer is just positive 9/4. Here I have 5/4 Now only 4 is being raised to the third. That means I have a 4 times a 4 times a 4 in the bottom, and only one 5. So the 5 stays in the top. If I multiply 4 times 4, that's 16. And then if I have 16 times 4, that's 64. And I can't reduce that, so I'm stuck with 5/64. For 7, we're going to evaluate an algebraic expression given a value of c being 5 and y being -6. The first thing you want to do, guys, when you have to evaluate an algebraic expression is rewrite the expression with parentheses instead of the variable. So I'm going to write negative parentheses plus 9 and then parentheses. This is really key because it's going to help us avoid making mistakes with these negatives when we plug them in. Now, I know that the c belongs in here. Now, instead of writing c, I can replace it with the number 5. And I also know that y is being multiplied to 9. So instead of y, I can replace -6 in there. So here I have a negative, and this negative you can think of as -1 if you'd like. This is -1 times 5. That's going to be -5. And then I have plus 9 times -6. Now 9 times -6 is -54. So when I do -5 plus -54, that's going to be a -59 if we add those sign numbers together. Okay, picking up with number 8. Here it's kind of interesting. It says rewrite the following without an exponent. So that means we have to somehow apply this exponent of -2. There's a key, and it's called the power of a quotient. If I have a quotient a over b raised to some power, let's call it m, basically I need to raise the numerator to the m power and the denominator to the m power. So I have a to the m over b to the m. What that means in this case is I have to raise 5 to the -2nd power and 9 to the -2nd power. Now another thing that you hopefully remember from Algebra 1 is anytime you have a negative exponent, you can change the position of that power and move it into the denominator or the numerator, wherever it's not, in order to make it a positive one. So for example, if I have 5 to the -2 in the numerator, I'm going to move that down to the denominator to make it 5 to the +2. If I have a negative exponent in the denominator of a fraction, I can move it upstairs to make it 9 to the +2. Now I can go ahead and evaluate those powers. 9 squared is 9 times 9, or 81. 5 squared is 5 times 5, or 25. So my final answer here is 81/25. Similarly, here I have -9 to the -2. Think about this as being in the numerator of a fraction. If I don't see a fraction, I can always write the expression over 1. Now, because there's a negative exponent, I'm going to drop this thing downstairs to the denominator to make it a positive exponent. When I do that, and this expression leaves the numerator, I'm left with 1 in the top. And now, check this out carefully. I'm going to have -9 in parentheses to the +2 power. Notice how I didn't change the -9. That negative is still there. The only thing that changed sign was the exponent. So what this really means is I have 1 over -9 times -9, which you guys know would be +81. So my answer is 1 over +81. In number 10, we're going to use the distributive property. So here what I'm going to do is I'm going to multiply -5 to the -y. I know a negative times negative is positive. That would be +5y. -5 times -4w is going to be just simply -5 times Okay, some more problems of a similar kind here. We're going to simplify these expressions, and in order to do that, we're going to need to do some distributing. So here, I'm going to distribute negative 2 to negative 6u. That's going to be a positive 12u. And if I do negative 2 times positive w, a positive times negative is going to be negative 2w. Now over here, I also have to distribute this negative, okay? So what I like to think of this as, oops, I kind of erased my negative 2w here. Let me rewrite that. I like to think of a negative in front of parentheses as being the number negative 1. Some students find that a little bit more helpful to distribute. So now I'm going to distribute negative 1 to a negative 3w. Now remember, negative times negative is positive 3w. And now negative 1 times negative 3u would be positive 3u. So now I'm looking for like terms. 12u's plus 3u's is 15u's. And then negative 2w's plus 3w's, those are like terms. I just add the coefficients, just like I did with the u's. So negative 2 plus 3 is positive 1w. I don't need to physically write that number 1 there. It's understood if I write w that there's 1w there. So that would be my answer for this problem. Number 12, we're going to simplify the following expression. All I'm going to do is look for like terms. I personally like to either circle or underline like terms. So like terms have the same variable and exponent on that variable. So for instance, 9x squared and negative 10x squared are like terms because they both are x squareds. All I have to do is add positive 9 to negative 10. And 9 minus 10 is negative 1x squared. When I'm done with them, I like to cross them out so I don't get confused by them later. Next, I'm going to look for x terms. Now, this is just negative 4. That's positive 10. Those will be added in a second, but the only x term I have is this guy. And I have nothing to add him to, so I'm just going to copy down positive 3x. Lastly, I have negative 4 plus 10 that I can add together. That's going to be positive 6. So you can leave your answer like that, but we don't need to write negative 1 really. We can just write negative x squared plus 3x plus 6 as our final answer here. Okay, in 13, we're solving for w. Right now, w is being multiplied by negative 3/7. So normally you might think, okay, in order to undo multiplication, we're going to divide by negative 3/7. But I hate dividing by fractions. It gets kind of complicated and ugly. Remember, we don't have a calculator, so we're going to try to do this the fast, simple way. So instead of dividing by the fraction, we're going to multiply by its reciprocal, which is equivalent to division. So the reciprocal, if you remember, of a fraction is just the flip of it, right? So I'm going to change this to negative 7 over 3. That would be the reciprocal. So I'm going to multiply both sides by that negative 7 over 3. And when we do that, negative times negative is positive. The 3's cancel because 3 divided by 3 is 1, and 7 divided by 7 is 1. On this side of the equation, we just get old w by itself. Now over here, I have a negative times negative. It's going to be positive. And remember, 21 is really in the top. I can divide 3 into 21 7 times. And now I'm just multiplying 7 times 7 to get 49. So I get 49 as my answer. 49 equals W. Let's see if we can solve number 14 for U. Now here, before I do anything, I do need to distribute and get rid of those parentheses. So I'm going to copy down negative 5u minus 18 here. And if I distribute negative 2 times u, that's negative 2u. Negative 2 times negative 6 is positive 12. Now, let me rewrite this so we have the room. We have negative 5u minus 18 equals negative 2u plus, negative 2u plus 12. And now I want to bring all the u's to one side. So I'm going to add 2u to both sides. If I do that, these cancel. And on the right-hand side, I just have 12. Over here, negative 5u's plus 2u's is negative 3u minus 18. Now I'm going to get rid of that 18 by adding 18 to both sides. And if I do that, I get negative 3u equals 30. Final step is to divide by the negative 3. And I get u equals negative 10. And that would be my answer. In number 15, it says an item is regularly priced at $40, and Lamar bought it at a discount of 30% off of the regular price. So how much did Lamar pay? Well, what we basically have to do here is take 30% off of that $40. So this is how I would set this problem up. I'm going to do $40, and what I'm going to do is I'm going to try to multiply that by 30%. Now, since we have limited use on a calculator here, I'm going to try to do this so we don't need a calculator. I can rewrite 30% as 30 out of 100. That's what percent means, right? Now, that fraction actually is a nice one to reduce, so I can change 30 out of 100 to just be 3 out of 10. So if I want 30% of 40, I can just multiply 40 times 30% as a fraction, which is 3 over 10. Now, I can write 40 as 40 over 1, and if I'm multiplying, remember, we can cancel common factors, and I know I can divide 10 into 40 and get 4. And I'm left with just multiplying the number 4 to the number 3, and that's 12. Now, that doesn't mean he got this for $12. That's how much he got off, right? That's taking 30% of 40. That's how much Lamar saved. So to answer the question, the original thing was $40. If we take that $12 off, which was the 30%, he's left with $28 that he ended up paying for that. Let's look at 16. Follow the instructions below. Write p squared times p to the fourth without exponents. So you should hopefully recognize if you multiply same bases, add the exponents. So it's just p to the sixth. All you have to do is add 4 plus 2. So I think this is the same problem on the bottom here. So p to the fourth times p squared should be p to the sixth power, right? P to the sixth. Okay, number 17. Let's see if we can simplify this. We're multiplying all this good stuff together. What I like to do when I'm multiplying an expression like this is multiply all numbers together first. So I'm going to multiply 2 times 4, which is 8, and 8 times 6, which is 48. So I get 48 to start. And I'm going to like to cross them out because I already took care of multiplying those. Now let's go to the y's. I have a y to the fifth, and then a y. Now realize a y is really a y to the first. And since there's 5 y's here and 1 y here, altogether there are 6 y's, 5 plus 1. There are 6 y's being multiplied together to be y to the sixth. So I am done with those guys. Now I have v to the fifth times v to the fourth. Altogether, 5 plus 4 is v to the ninth. So that would be my answer for this guy. Simplifying radicals. If you have a radical, you should always try to factor it down into its prime factorization. So I like to use the factor tree. So 45 I know is 9 times 5. When I'm stuck with a number I can't break down, I like to circle it. And then 9 I could break into a 3 times a 3. And so I'm stuck with those 3's. So the square root of 45 is the same as the square root of a number 3 times the number 3 times the number 5. If you have a pair of the same numbers, you can pull them to the outside of the fraction, and you're left with just 1 3 in the front. That's the square root of 3 times 5. Again, hopefully that is just a quick review of simplifying some fractions, or excuse me, radicals. Now looking at 19, we have to do this without a calculator. We're dividing 7/16 by the fraction 5 over 14. Now remember, let's see if we can rewrite this problem slightly. I'm taking 7 over 16 and I'm really dividing it by 5 over 14. Now division is the same as multiplying by the reciprocal of the number. So 7 over 16 stays, but I'm going to multiply by the reciprocal of that guy, which is 14 over 5. Now, if I can, I'm going to cancel some common factors. I really have in the top 7 times 14, and I have 16 times 5. I know 2 goes into 14 7 times, and I know 2 goes into 16 8 times, so I was able to cancel out those 2's. And I don't think anything else cancels. I have 7 times 7, or 49 in the top, 8 times 5, 40 in the bottom for that problem. So 49 over 40. Okay, number 20 is a complex fraction. When you have something like this, your first job is just to attack this, let me get rid of that. Your first job is just to attack that top fraction. So I'm going to try to combine those first, and then I'm going to combine those to get one fraction in the top and the bottom. So for this one, to add 3/8 and -1 together, I have to get an LCD, which of course, the common denominator here, if I write 1 over 1, would be the number 8. So I have 3 over 8, and if I give this a common denominator of 8, it'll be minus 8 over 8, and I can write that as 3 minus 8 over the number 8, 3 minus 8 being -5 over 8. So that's really my numerator. In the denominator, I'm going to write that as 1 over 1. The LCD for the denominator is 4. So to make this have a common denominator, I have to multiply 1 by 4 over 4. So this changes to 7/4 plus 4 over 4. That's 11 over 4. So this problem now I've just changed to be this. -5/8 divided by by 11/4. So similar to what we did in the previous problem, I'm going to take the numerator's fraction, the -5/8, multiply it by the reciprocal of the denominator, which would be 4 over 11. Now one of the things I noticed to make my life easier is I know 4 goes into 8 2 times. So I end up with just -5 times 1, or -5 in the top, and then 2 times 11 is 22. That would be my answer for this one. 21 is talking about a relation. Now a relation, this is called set notation, okay, where you use these brackets here and here. And now if you recall, when you write coordinates, it's always the x coordinate followed by the y coordinate. And very simply, guys, the x value has to do with your domain. That's like what you're plugging in, and the y values have to do with what we call the range, or the outputs. So what this is asking for is give the domain and range of t. So if I want the domain, all I have to do is use these fancy brackets for the set notation, and all I have to do is list all of the x values. The x values are 9 and 0 and -7, and now -7 is repeated twice. I don't really need to write -7 twice. I can just write the x values, basically. So keep in mind, those are just the x values. The range, remember, that's just the y values. So the range of this guy are only the y values. That would be the -8, a 9, a 4, and a -5. That would be my range. Okay, and for number 22, it says, for each relation, decide whether or not it's a function. To be a function, it's important that each input, which has to do with the domain, each input from the domain has only one output, or one output in the range. So what I'm going to look for when I look at in relation 1 here, the desk only has one output. Paper has only one output. Sun and rock, these all have only one output. Granted, it's the same output of -8, but that's okay. This would be a function. If you take a look at this relation, number 2, right off the bat, look at cloud. Cloud has 2 different outputs in the range. A cloud can go to S, and cloud also goes to D. That is not allowed if it's a function. So I know right away that's not a function. Cloud has 2 outputs in the range. Check out relation 3. Now, keep in mind, the inputs are the x values, right? Now, right away, the input of -3 has an output of -3 in this pair, and the input of -3 has an output of -4 in that pair. That'd be like saying, okay, -3 goes to the -3 in the output and -4. As a matter of fact, -3 even goes to, I think that was a 9 in there. So it even goes to a 9. So the input this input of negative 3 has 3 different outputs. That's not allowed. That's not a function. And take a look at this one. I have input of k going to k. There's no other inputs of k. I have an input of b going to g, and there's no other inputs for b. What I'm looking for is repeated inputs, like, oh, I have an input of g in my domain for my x value, right? And it goes to either k, if I'm in this coordinate, or it goes to g in this coordinate. G, I should write that as g. G has 2 outputs. That is not allowed, so that would not be a function. In this example, 23, we're going to do something that you probably remember, know and love. It's called FOILing. When you have a binomial times a binomial, we're going to multiply the first guys together. That would be u times u, or u squared. Then I'm going to multiply the outer guys together. U times negative 5 is negative 5u. Then I'm going to multiply the inside guys together. 1 times u is just 1u. And then 1 times negative 5 is negative 5. Now always look for like terms usually in the center you can add up. So this would be u squared. Negative 5 plus 1 is negative 4u's. And then if I copy down the negative 5, I'm done. Those are no longer any like terms, and I'm stuck there. A little bit trickier, but the same idea. I have a binomial times a binomial. I'm going to FOIL again. 5a times 5a is 25a squared. 5a times 8b, I can multiply 5 and 8 to get a positive 40. And then a times b, I can only write as ab. There's no magical way of multiplying a and b together. And now negative b times 5a is going to be negative 5ab. And then if I do negative b times positive 8b, that's going to be negative 8b squared. So I'm going to have a negative 8b squared. Now I have to look for some like terms. And I think I have them right here. There is no other a squared term, so I'm going to copy down 25a squared. 40ab's minus 5ab's is positive 35 if I subtract 40 and 5. And then the ab stays the same. And then I copy down negative 8b squared as my final term there. Now number 25, a lot of students get confused about, but realize, guys, when you square something, it just means you multiply it by itself. So it's u minus 4 times u minus 4 twice. That's what squaring means, right? If I had 9 squared, that's 9 times 9. It's no different when you have a binomial squared. So this is just another way of getting you to do FOILing. So u times u squared, u times negative 4 is negative 4u, then another negative 4u for the inner terms, and then negative 4 times negative 4 is positive 16. So I have u squared minus 8u plus 16 as my final answer there. And finally, on the last page, I have to use the distributive property to remove the parentheses. So again, we've done one like this earlier. I'm going to distribute that 9x to the 6th times 8x squared. So 9 times 8 is going to be 72, and x to the 6th times x, that's a total of 7 x's being multiplied together if you add those exponents up. So that first term is just going to be 72x to the 7th, and then I have to do 9 times 7 here, that's going to be positive 63, and then x to the 6th times x squared, that's a total of 8 x's if you add 6 and 2. And I can't add these up because they're not like terms, so I'm stuck with that as my final answer. For 27, find the greatest common factor of those two. I'm going to show you a little trick that I learned from another teacher that I kind of like. If I'm trying to find the greatest common factor, I use this like table. Maybe you've seen this before too. So I'm going to write 9x squared and 6y to the 3rd next to each other, and I put a little bar here. Then I ask myself, is there anything I can divide out of both 9x squared and 6y to the 3rd? And hopefully you recognize you can divide both 6 and 9 by a 3. So if I divide 9 by 3, I get 3x squared here, and 6 divided by 3 is 2y to the 3rd. Now these have no other things in common. 3 and 2 I can't divide anything, and then x squared and y cubed have nothing in common. So whatever it is that you pull out here, that's just your greatest common factor. So I would say that 3, that's my answer. That's the greatest common factor. It's the biggest thing you can divide out of both of the given terms. And then for this guy, number 28, if I have to factor that, basically all I can do is look for the greatest common factor. So maybe we'll use the same kind of trick. Let me see what I can divide out. I can divide a 3. 6 divided by 3 would be a 2y squared. And I can divide 9 by 3. That would be a positive 3y cubed. Now I can't divide out any other numbers, but I have a y squared here and a y cubed there. That means I could divide out a y squared from both. If I divide 2y squared by y squared, I'm just left with 2. If I divide y to the third from ny squared, I'm left with just a 3y. So now at the end of the day, this is my greatest common factor, the product of 3 and y squared. So I really pulled out a 3y squared, and I'm left with 2 plus 3y. So 2 plus 3y would be left in the parentheses. An easy way to check is to distribute 3y squared times 2, that would be 6y squared, and then 3y squared times 3